Okay, so this is Geometry Notes 9.1. All right, we've split this across a couple different days, so it's not going to be done in just one day. So if you missed on Wednesday, you just missed parts of this lesson. The other part was done on Thursday. Okay, so we really want to get into the definitions today. We can all be on the same page for later on. All right, so for introduction, this is what we call a circle cube. It's a circle, but circles are mainly defined by their center. Even though the center isn't a part of the circle, we still call this circle Q because it's centered at Q. Part of the reason for that is based on the definition of what the center of a circle really is. The center of a circle is a special magical place inside the circle that just happens to be the same distance from every single point on the circle. Okay, so no matter where I'm at on the circle, I know that Q is the same distance away. That also lends credence to what we call a circle and how we define what a circle really is. A circle is a set of all points in a plane that are equidistant from a given point. Basically, this is a collection of all of the points, every single little teeny, put all these little dots, every single little teeny tiny point, all of those that are the same distance away from Q. So if I drew little lines here, every single point would be the exact same distance away from Q. All right, so if we, on your notes, you're going to label the circle, show that the name of circle is circle Q. So on your notes, it's going to look something like this. I'm going to go all the way to the top. Okay. So in here, you're going to want to label this circle Q, just like you see, not that one, just like right here. So put a little Q here. I want to pay special attention to this little symbol right here. This is the symbol for circle, Q. All right. So if you ever see this symbol, you need to know that it means circle. Okay. Once you got that done, now we're going to talk about a radius. The definition of a radius is a line segment whose endpoints are at the center and on the circle. So we got one on the center and one on the circle. It's very specific to make sure we pay attention to the line segment. It's not a line. It's a line segment. That means it stops. Boom, boom. All right. Also, one is at the center and one is on the circle. One at the center and one on the circle. So on your note, you're going to draw a point R right here, and you're going to write down radius right here. So you can see QR is a radius. So that looks like right here. You're going to draw a little R up here, connect them, and then label it radius QR or RQ. Okay. Notice the symbol above. Super important. You need to make sure that you're writing your symbols about what we're talking about. If it's a segment, put the segment symbol. Okay. Chord. We're not talking about music chords. We're not talking about piano chords. We're talking about math chord. And a math chord is just a line segment that touches the circle in two places. That's it. It's a chord. Now, a chord can be made into different things, but right now we're just talking about it just being a line segment with points on the circle. And a diameter is a very special kind of chord. So if the chord is moved up until it magically rests right through the middle of the circle, then it becomes a diameter. Now again, notice the diameter, it has to have endpoints on the circle, and it has to go through the middle. So a radius could never be a diameter, because a radius has one endpoint in the center, whereas a diameter has to have both endpoints on the circle. Okay. All right, so on your picture, your notes, you're going to want to put this picture down. Again, it still looks the same. You just got to put a P over here and an S over here, and then you're going to draw it just like this. So we know that PS that we're drawing here is a diameter because it goes through the center and it has endpoints on the circle. That's what we call a diameter. Remember, this is mainly a vocabulary lesson trying to understand what we mean when we say certain things. Now I want you to draw TU on the circle, and we're going to call it a chord. TU, since the endpoints are on the circle, and it's not through the center, we call it a chord. Line segment with endpoints on the circle is a chord. Now, if we talk about what's called a tangent line, I don't want you to draw it there. I actually want you to draw it over here on your circle. Use T and draw a line that only touches the circle just right at T, and that is what we'll call a tangent line. Something that touches the circle only in one spot is a tangent line. All right, we use these a lot. We'll talk more about it later, but tangent line touches it only once. A secant line is a line that touches it twice, just like a chord, but it keeps going on forever in both directions. So chord, line, segment. Secant, line. Not a segment, a full line. Okay, same with a tangent. A tangent has to be a line. So when we talk about, when I ask you to write the secant, let's go with the next one right here, and I say the secant line, notice how it has this little arrow symbol above it. That means it's going in both directions forever. Not just a segment like a chord, but it's actually a line, WX. Okay, so point of tangency. It really doesn't have to be explained, but if this line is tangent to this circle, that means it touches at a specific point. Well, that point, we call it the point of tangency. It's where the tangency happens. So you may want to write this in on your paper. Tangency, little arrow to T, that's where it happens at. So if you see a vocab word, point of tangency, there it is. So let's talk about how many chords do we see in the diagram. I want to think about it, pause the video if you have to, but I want to talk about how many chords you see. I see U, and we named it as a chord. It can be written on your paper. Now the diameter, PS, that's also a chord. The last one is, I know you're going to be upset, but WX. Notice how the secant line had those arrows? Well, if I take off those arrows, then it becomes a chord, WX. So a secant line, if it continues both directions, is a secant. But if I cut it off and just have WX as a segment, it's a chord. Now let's talk about how many radii we see in the diagram. Well, the first one we named it as a diagram, as a radii, but the other two we got to think about a little more. PQ, does it have an endpoint at the center? Yes. Does it have an endpoint on the circle? Yes. Then it's a radius. All right. QR, we labeled that one as a radius, and then QS is also a radii. Okay. Usually like 7 minutes of working on homework. So if you want to take a break, work on this for 7 minutes, pause the video, come back. It's fine. Otherwise, we're going to go on. But you need to be able to do those homework problems before we go on. All right. Intersecting circles. Points of intersection. Again, we have top and bottom. I can see it's touching in two places. That means it's not tangent because it touches in two places. Tangent means touches only in one spot. Now notice here, we have coplanar circles that intersect at one point are tangent circles. These two circles are tangential. They only touch on one spot. There's two different kinds of tangent circles. One's on the inside. Notice how these are internally tangent because one of the circles is inside of the other circle. Okay. We also have what's called externally tangent, which means both the circles don't overlap. They're not, one's not inside the other. They're next to each other. And if you notice, you can kind of make this kind of look like a face. You put the nose and the mouth on there. It's kind of cool. So common internal tangent, new definition. Common means it's shared between two circles. Internal means it's going to cut across the middle of the two. And then tangent means it touches in one place. So common internal tangent is a line that passes through two circles, and it passes between the two. Okay, I can also make this look like a nose and a mustache. Anyway, common external tangent in concept. Common means it's shared between two of them. External means it's on the outside of the two circles. And tangent means it touches each circle in one spot only, or the unibrow. That's how I think about it. Right, so over here, we're going to draw the common external tangent circles C and A. Well, there's one. Is it common? Yes. Is it outside the circles? Yes. There's the other. Now it says draw the common internal tangent. Now this one's not drawn very well, but I want you to see, well, it's drawn well, it's just that you can't see it because it's so big. I want to tell you what's exactly going on here. I have here two circles. Okay. And I'm connecting it where it touches once right there and once right there. And then I'm drawing where it touches once right here and once right here. That's where that X shape comes from. You got to make sure that your tangent lines touch both circles at one point only. Okay. All right. Now, that's that one done. Now it says draw common external tangent to C and D. Now, again, we just focus on C and D only. That's external. That's external. We're done. Common external tangents. Now notice how these two circles, they themselves are externally tangent. Isn't that interesting? When I ask you to draw the common internal tangents for C and D, notice, well, they only touch at one point particular, right there. When I draw the common internal tangent, I only have one of them. I can only touch at that one spot where the two circles are touching. So there's your common internal tangent. All right, now it says draw a common internal tangent for C and D. Done that already? Okay. Oh, last concept. Oh, goodness. There we go. Concentric circle. So in Spanish, con means with. So like voy a ir con mi amigo, con means with. So when we think about the word with and then centric, centric is very much like center. So concentric circles are circles with the same center. It's kind of your little vocab, my attempt at being an English teacher. I'm not very good at that, but we'll work. All right, so circles that have the same center. Concentric circles is how I think about it. There's this first circle. If it has the same center, we can just draw it a little bit smaller. And then we could do another one that's a little bit smaller than that. Each of these are concentric circles. They have the same center, and they're just different sizes. They can be bigger or smaller as long as they have the same center. So now the instructions are draw two concentric circles with A. Now your compasses in class are too big. They won't draw concentric circles on this diagram, but you'll just have to hand draw it in there. There's one concentric circle and there's another. Do it as best you can, as long as you know what it means to be concentric circles. So when you go back and look over these notes, you'll be able to know, hey, that's what that means. So right here, take a minute and explain why there are no common tangents for B and C. Why can I not be tangent to B and be tangent to C? So pause the video if you want to. Think about this a little bit. But if I drew a tangent, draw a tangent line to B. Okay, so if I draw a tangent line to B, is there any way for it to touch B one time and only touch C, circle C one time? No, because B is on the inside of it. If B is completely inside and they're not internally tangent, then there's no way to have a common tangent. Ooh, very nice. Inscribed versus circumscribed. Okay. If we have a triangle or any shape, any polygon, with all of the vertices on a circle, then the polygon is said to be inscribed in the circle. We've discussed this before in class. So again, we have inscribed and circumscribed. Well, the heptagon is inside, right? So that's inscribed. But the circle is on the outside. So we say the circle circumscribes the polygon, touches each point on the polygon. Okay? We can also look at this as an octagon here. Which one's inside? The octagon is on the outside, and the circle's on the inside. So we would say the octagon circumscribed the circle, and the circle inscribed the octagon. What's cool about this circle is when you inscribe it on the inside, each one of these sides are tangent to the circle. So each one of these only touch at one spot only. That's the definition of inscribed circle. Okay. Oh man. Funny. That was from class earlier. In class earlier, we had about 10 minutes to work on homework right here. I think I gave 9 actually. So if you want to work on homework for a bit, pause the video, come back. You should be able to do problems 10 through 18. All right. Now, if you did your homework, if not, here we go. Two circles are congruent if they have the same radius. So circle N has a radius of 2 and circle M has a radius of 2. Therefore, circle M and circle N are congruent. Now, this is a biconditional statement. So two circles are congruent if they have the same radius. Also, if two circles have the same radius, then they are congruent. So we're going to use this information on these next couple of questions. Several radii are drawn in the same circle. That's something kind of like this. Okay, I've got a whole bunch of radii in this circle. And in congruent circles. So now I've got them also over here in this other circle that's congruent. What can you say about their lengths, about all these red lines and radiuses? What can you say about all of them? Again, two circles are congruent. They have the same radius. That means all the radii are the same. Next question. Why can't a radius be a chord? We need to look at the definitions. A radius is a line segment with one pinpoint on the center and one endpoint on the circle. But a chord, by definition, is a segment that matches whose endpoints are both on the circle. So since the radius has an endpoint on the center, it can't have both endpoints on the circle. So it can't be a chord. Why can't a line, notice this red, line and segment, why can't a line that contains the center of a circle be a diameter? Because by definition, a diameter is a chord, and a chord is a segment. So it can't be a diameter because it's a line, when it should have been a line segment. There's your essential question. Here we go. I love this question. Okay, so circle J and K are congruent. That means they have the same radius. L and M are congruent. They have the same radius. X and Y are congruent. They have the same radius. So if I'm trying to find out the whole length of these red lines, I'll add them together. That's exactly what I do. I just add them all together. The diameter of J is 6. Well, I don't want the diameter. I want to know what the radius is. So the radius is half of a diameter. So I say that's half of this. It's 3. Half of 4 is 2. So each one of these is 2 pieces, or 2 kilometers long. The Y, the diameter is 2. So the diameter here is 2. Here, this radius is 1, and this radius is 1. This one's 2 and 2, and this one's 3. So basically, we're going to do 3 plus 2 plus 2, plus 1 plus 1 plus 1 plus 1, plus 2 plus 2, plus 3. Okay? Just like this. 3 plus 2 plus 2 plus 2 plus 2, plus 1 plus 1 plus 1, plus 3. So we've got 6 plus 4 2's, which is 8, plus 4 1's, which is 4. So we should have 18, it sounds like. But I'll leave that up to you. They're your notes. All right. I'll help you with problem 19 on your homework. All right. At this point, we stopped in class. We were done for the day. Thursday, we're going to come back and we're going to finish off the lesson. So I'm going to finish it right now because we don't have much left. You're going to skip example 9.4. If you get the notes from this YouTube video, then you get extra credit. Okay. So let's go ahead and do that right now. I'm going to take this off, YouTube video only. All right, so right here, you have to use what's called special right triangles. All right. So I'm going to make sure I do this right by going to your notes. Oh, too far. All right, right here, 9.14. I'm going to zoom in a little bit. It tells us to find the length of AB. Oh, man. What is going on here, people? It was all working perfect, and then it ruined it. All right. So looking at this symbol right here, I'm going to bring up my comment tools. We're going to do this problem together on the notes. So if I draw a drop-down segment right here, I know that this is 6. Well, it's an OB as a radius. So is OA. They're both radius. So that means it's a 6 over here. That tells me it's an isosceles triangle. So if I drop down the altitude, I have a 90-degree angle. I did it again. 90-degree angle right there. And this one's 6. That's the hypotenuse. Okay. And so I need to be able to find out, oh, well, hey, this is 60 degrees. If I cut this in half, I get 60 degrees. And if this is 60, this is 90, and this is 30, there's your 30, 60, 90. That means we're going to use special right triangles. So if I come back over here to the notes, I used my special right triangle. This right here is supposed to be equal to 6, which means that x equals 3. So this is going to be a 3 over here. And this one down here is going to be 3 root 3. So I'm going to bring that back over to my notes. And I'm going to say this distance down here should be 3 root 3. But that's only 1/2 of it. So that means that since it's an isosceles triangle, this one over here is also going to be 3 root 3. When I add those two together, I have 3 root 3s plus 3 root 3s. So how many total root 3s do I have? Oh, geez. Delete that. Okay. I have total 6 root. No, not 6s. I have 6 root 3s total. I've got 3 here, 3 here. Total together gives me 6. So my answer should be 6 root 3 on my notes. Again, just get those down in your notes. That's extra credit. If you do them on the homework, then it's even more extra credit. So you should know how to do special right triangles. Not required, but strongly recommended. Okay, so I'm going to put those red X's back up here. We're not going to do them in class. All right, now with that, we've got circle M. Here's circle M. The interior of the circle is everything inside the circle. The exterior is everything on the outside. And that's only going to help for the questions where I actually read stuff. So you have to take the word problems. And if I say, well, point B is on the exterior of the circle and M is on the interior, then you'll have to know what those mean when I say them in the question. So if a line is tangent to a circle, then it is perpendicular to the radius drawn at the point of tangency. This is huge. We use this so much this year. All right, so P right here, this is the point of tangency. And so the line L is tangent. That means I get a 90-degree angle right here with this radius. It's super important that you know that tangents are perpendicular to radii. Okay. All right, in a plane, if a line is perpendicular to a radius of a circle at its endpoint, then the circle is a tangent. All right, so that's also going to help us prove tangency. So if I can show that this is the radius, they're both on the endpoints and on the center, and if I can prove that this angle right here is 90 degrees, then I know that it's tangent. So just imagine for a second here, and I gave you a triangle built out of this shape. Okay, I don't tell you it's 90 degrees yet, but I tell you that I give you the lengths. Let's say this is a 3, a 4, and a 5. Well, you know that is a Pythagorean triple. So you could say that this has to be a 90-degree angle because it's a Pythagorean triple. And once you show me it's a 90-degree angle, then you can say that L is tangent. I have an example of what you're going to be doing with this whole point of tangency concept. All right, more information for you. Two segments from the same exterior point, remember exterior is on the outside, all right, are tangent to a circle, then they are congruent. So if two segments, we're talking S is the outside point, and SR is tangent, and ST is tangent, then SR segment is congruent to ST segment. Okay. We can talk about that more later on the homework and things, but it's important to know that one. Here we go. That's what I was talking about as far as perpendicular, right? RS is tangent to circle P at R. See that? So that's why we get the 90 degree from, because it's tangent. If PR is 5, RS is 12, find PS. PS. If you have your cheat sheets or your blue sheets, you'll look at the Pythagorean triples and you'll see 5, 12, 13. And you're done. PS is 13. It's a Pythagorean triple. But if you don't have those, then you've got to do the long way. Okay, so let's see here. I went one too far. Oh, what am I doing here? All right, here we go. So if you don't have it, then you got to do 5 squared plus 12 squared is equal to C squared. And this ends up being 144 plus 25. That gets you 169. Square root both sides. And C equals 13. All right. So if you don't, you got to do all this extra math if you don't know your Pythagorean triples, which is why I told you to memorize your Pythagorean triples. So again, right here, example 9.6, we're not doing it as far as the class goes, but if you do it on YouTube and you get extra credit in your notes, you'll also, if you do it on the homework, then you'll get even more extra credit. So let's find that question in the notes, and we'll work it out together. Okay. What it says here, oh geez. I want to turn off my comment. I want to get back to my selector. How do I do that? No, I want that off. CB and CD are tangent to O and B at B and D respectively. All right, so right there off the bat, I know that CB and CD are congruent because they're tangential from an exterior point to the same circle. Okay, that came from our notes. So now it says that if OC is 2 root 7, here's OC, that's this big triangle right here. Oh man, that was terribly drawn. CO right here, that line right there is 12 root 7. And BC, this bottom part right here, is 5 root 2. Come on. Okay. Find AB. Oh, I need this whole side. Well, AB is a diameter, so if I can find the radius. What's going on here? Okay. Oh, cancel. Oh, cancel. All right, 5 root 2. I need to find this little segment right here, and then I can just double it. So I'm going to use the Pythagorean theorem. I'm going to say that 5 root 2 squared, the whole thing squared, plus, I don't know what, we'll call it b squared, is equal to c squared. The hypotenuse here is going to be 2 root 17. And that squared gives us 4 times 17, right? Root 17 squared is 17. 2 root squared is 4. Over here, I get 25 times, oh my goodness, times 2. Because root 2 squared is 2, 5 squared is 25. That gets me 50 plus b squared is equal to, oh man, what's 4 times 7 is 28. Carry the 2, 68, I'm thinking. Give me a sec. 14, 28, yeah, 68 is equal to 68. Well, now I got to subtract 50 from both sides. Subtract 50 from both sides. Gives me b, that's not a b, that's a d. Let's go with b squared is equal to minus 50, gives me 18. I square root both sides, and I get b equals square root 18. Now, if I double that, then I end up with 2 root 18. And I can simplify this by getting, let's see here. I just lose everything. Just lost everything. So anyways, I had 2 root 18, and I split that to be a 9 and a 2. Well, the 9 splits to be a 3 and a 3. So I can pull that out in front, and I'm left with 3 times 2 root 2, which is 6 root 2. So there's my final answer. If you filled all that into your notes, you'll get tons of extra credit, and do it on the homework, and you'll get even more. So let's go back to the notes section. Okay, I'm not doing that in the homework. So work on problems 19 through 21. And then there's a calendar. Here's your summary. Make sure you write in your summary. We have some homework problem slides that I can help you with. But I'll just come over here, zoom out, and we'll find the homework page. Where is it? Okay, 9.1. Okay, so 11. Draw a large circle. Inscribe an isosceles triangle. Oh, see, it's so hard to do that. I can't do it. We could do this though. Isosceles triangle. These are the same size. And I could draw a circle around it. Well, apparently I keep moving it. That's all I want you to do. Just draw it. I wish I could do it on my other device, but that's okay. These ones up here are pretty straightforward. Just name the secant line. The secant line is going to be CF, by the way, just in case you were curious. Back page. Again, remember all these? These are 22 through 27. They're all extra credit. I strongly recommend it. But you should be able to do 19, 20, and 21. No problems. Yeah, there's your notes. There's your homework. That's everything you need for 9.1. Day and a half worth of class. So do your homework, fill in your notes.